Okay, there's pitch over. 64, yes, pitch over, yes, sir. There's pro.
For 5 years, the world has been sold a simple idea. Humans are going back to the moon. We've seen the high-fidelity renders. 2 astronauts descending to the lunar South Pole, planting footprints in a place untouched for over half a century. That is the promise of Artemis III. But as we stand here in April 2026, the reality is far more visceral. This mission doesn't begin on the lunar surface. It begins with a logistical chain of events that has never been successfully completed. Not at this scale, and certainly not with human lives on the line. If a single link in this chain snaps, the mission ends before it ever truly begins. At the centre of the architecture sits the Space Launch System, the SLS. It is a machine built for a singular brutal purpose, to punch through the atmosphere and throw a crewed vessel into deep space. Inside sits the Orion capsule. For the crew, the moment of ignition isn't a visual event, it's a physical assault. The vibration builds instantly, a violent structural shaking that travels through the marrow of your bones. Within seconds you are pinned. 3 times the force of gravity presses into your chest, forcing the air out of your lungs and turning simple breathing into a manual labour task. There is no easing into this, it is relentless, because at this stage of the flight there is zero margin for error. As the rocket climbs, the world below dissolves. The atmosphere thins, the sky bruises into a deep purple, and then total black. Within minutes, the crew isn't just flying, they are leaving the cradle. Once Orion separates from the spent core stage, the violence vanishes. It's replaced by a silence so heavy it feels physical. For the first time, weightlessness takes over. Objects drift, straps loosen. But outside the glass, a terrifying psychological shift occurs. Earth is shrinking. What was once an entire world becomes a blue marble, bright and fragile. As they move further out, the environment becomes far less forgiving. Communication delays begin to stretch. There are no nearby stations, no immediate rescue. This isn't low Earth orbit, this is the void. From here on out, they are on their own. But reaching deep space isn't the hardest part of Artemis III. What comes next is the true engineering gamble. Before a landing can even be attempted, Orion has to meet a ghost ship already waiting in orbit. This is where SpaceX enters the mission with the Starship human landing system. To call this a lander is a massive understatement. It is a 50-metre vertical skyscraper, but it has a fundamental physics problem. Starship cannot reach the moon on its own if it launches fully fueled from Earth. It has to be fed in space. This requires a relentless conveyor belt of tanker launches, one after another, lifting off from Texas and Florida, docking in orbit, and transferring cryogenic propellant slowly, precisely, under the extreme temperatures of space. Think about the industrial scale of this. We are talking about moving hundreds of tons of liquid methane and oxygen between 2 massive spacecraft while travelling at 17,000 miles per hour. If the fuel gets too warm, it boils off into gas and is lost. If the transfer valves freeze, the mission is paralysed. This orbital gas station has never been operated at this scale. Every connection must seal perfectly. Even a microscopic leak of liquid methane can cascade into a total mission failure. Only once Starship is topped off can Orion approach. The docking is a tense, millimetre-level ballet performed at thousands of kilometres per hour. If the docking latches don't cycle, there is no landing. Once the connection is hard-locked, the crew performs a historic transition. They move from the compact, rugged Orion into the vast industrial interior of Starship. This isn't just a move between ships, it's a transition in capability. From here, the mission pivots toward the lunar South Pole. This isn't the Apollo moon. The Apollo missions landed near the lunar equator, Where the sun is always high and the terrain is relatively flat, the South Pole is a landscape of extremes. Here, sunlight behaves like a liquid, pooling on high ridges, while leaving craters in permanent soul-crushing darkness. In these permanently shadowed regions, the sun hasn't shone in billions of years. Temperatures drop to minus 415 degrees Fahrenheit, colder than the surface of Pluto. This is a place that can turn standard engineering materials into glass. But within those shadows lies the mission's gold, water ice. As Starship begins its final descent, the engines kick up a nightmare: lunar regolith. This isn't sand, it's sharp, glass-like, and electrostatically charged, because the moon has no atmosphere to slow it down. This dust doesn't just settle. When the Raptor engines fire, the regolith erupts in a supersonic cloud that blinds sensors and sandblasts the landing gear. This is a controlled descent through total uncertainty. There is no abort in the final seconds. You either land or you're gone. For the first time in over 50 years, humans stand on the moon. But it won't feel like the 1960s. Gravity is a mere 1/6 of Earth's. Balance shifts. Every step is an unfamiliar floating stretch. And the silence is absolute. No wind, no atmosphere, no sound. The environment is unreal, but the danger is concrete. The Axiom-U suits protecting the crew are masterpieces of mobile engineering, but they are the only thing standing between the astronauts and a vacuum that wants to boil their blood. These suits have to be more than just pressurized bags. They are independent spacecraft you wear. They must manage the extreme heat of the sun on one side and the absolute zero of the shadows on the other. If lunar dust breaches a joint seal, it acts like sandpaper, grinding away at the life support systems. If the thermal systems fail against the South Pole cold, there is no backup. Above them, the radiation is constant. Without Earth's magnetic field to protect them, the crew is being hammered by invisible cosmic rays every second they remain on the surface. This radiation isn't just a long-term health risk, it's a threat to the onboard computers. A single bit flip caused by a solar particle could crash the navigation software. Every minute on the surface is measured. Every breath is a calculated cost. Because Artemis III isn't just a return, it's a system test for a permanent presence. We aren't just looking for rocks, we are looking for a way to live off the land. The ice in those craters isn't just for drinking. It can be cracked into hydrogen and oxygen, the ingredients for rocket fuel. This surface could become the first refueling hub of a multi-planetary species. The Moon is the 8th continent, and Artemis III is the first survey of its most valuable real estate. Mars, deep space, the stars, it all starts here. But none of that happens unless every link in the chain, the launch, the orbital refueling, the docking, and the descent, works perfectly. Artemis III isn't a victory lap. It's a fragile, high-stakes bridge to the future. It is the most daring industrial project in human history, carried out in a vacuum that doesn't care if we succeed. And this time, we're not just visiting, we're learning how to stay.
That's one small step for man, one giant leap for man.